square by 4 minus y square. Okay, when you solve this equation, you'll get the value of tau as 6x upon bd cube into d square by 4 minus y square. Okay, now we will find out the value of shear stress at the top edge AB. Okay, now if you see at the top edge AB, what is the value of y? So y is equal to d by 2. Okay, so we'll substitute the value of y is equal to d by 2. So now case 1, what is the case 1? Case 1 is, case 1, value of tau at top edge, okay, and the top edge is denoted by AB. So at top edge, y value is equal to what? D by 2. So we'll substitute in our equation tau, that is equal to 6s upon bd cube into d square by 4 minus, what is the value of y? So the value of y is d by 2. So y square, it will be d square by 4. So we get the value of tau at top edge AB, that is equal to 0. Okay, we get the value of tau at edge AB is equal to 0. Now we come to find out the value of tau at neutral axis, right? So at neutral axis, what is the value of y? So at neutral axis, the value of y, that is equal to 0, because it is increasing from here to the top edge. At top edge it was d by 2 and at neutral axis it is 0. So now our case 2 will be, substitute the value, case 2, tau at neutral axis. Okay, so at neutral axis, y value, that is equal to 0. So now I will put in our formula tau, that is equal to 6s upon bd cube into d square by 4 minus, what is the value of y? 0. So what we get? 6s upon bd cube into d square by 4. Okay, this will get cancelled out. So what we get? We get it as, this is 2 2s are 4, this is 2 3s are 6. So we get 3 by 2 into s into, this has been cancelled out, so upon b into d. What is b into d? B into d is nothing but the area of a rectangle. So we can say 3 by 2 into s upon a. Okay, and what is s upon a? S is nothing but the shear force. And what is a? Is area. So what is force upon area? Force upon area is nothing but, the tau average. So I can say 3 by 2 tau average, that is nothing but tau. So at neutral axis, we get the value of tau as 3 by 2 tau average, and that value we will obtain it as maximum. So we can say tau max, that is equal to 3 by 2 tau average. So now if I want to draw the, which diagram? Shear stress distribution diagram. What I will do? I will draw a vertical line at the top edge, bottom edge and neutral axis. Okay, we will take all the values horizontally, draw a vertical line. At top edge AB we have observed 0. As it is a symmetrical section, definitely at the bottom it will be 0. And at neutral axis we have observed it is maximum. Okay, and what is the value? The value is 3/2, which is 1.5 tau average. So we can join these points. So this diagram is called as stress distribution diagram. We call it as shear stress distribution diagram. Okay, where the shear stress value is 0 at top, at bottom, and maximum at neutral axis. Okay, so now based on this we are going to do one numerical, that is we are going to solve a numerical for a rectangular section, because in the next session we are going to take I section and T section. So we'll take one problem based on this. So the problem is, we have got a rectangular beam, because I'm taking a rectangular section. So the problem is that we have got a rectangular beam. So I'm writing down what is given. Given is a rectangular beam having width 150 mm. So B, that is equal to 150 mm. It is subjected to maximum shear force. So maximum shear force, it is 150 kilonewtons. Okay, maximum shear force, which is denoted by S. Okay, so 150 kilonewtons, and the corresponding shear stress is 5 Newton per mm square. So you can see they have given you the shear stress value, and shear stress is denoted by what? Tau. So tau, that is nothing but 5 Newton per mm square. Okay, you have to find out the depth of the beam. What will be the depth of the beam? Okay, this is the problem they have given, that we have got a rectangular section. So I can draw over here that we have got a rectangular section. They have given the width of the section. So what is the width of the section? Is nothing but 150 mm. Okay, depth we have to find out. Okay, so what is our formula? Everybody should now be able to remember, because it is very simple. Tau, that is equal to say by. So say by, right? Now they have given you the value of tau. They have given you the value of shear force. What we have to find out? We have to find out the value of area. We have to find out the value of y bar. We have to find out the value of I, and the B is already given. Okay. So to start with, first is area A. What is the value of area for a rectangular section? B into D. Right. So B into D, we can find out the value of area. Second is what they have told you to find out the value of y bar. What is the value of y bar? D by 2. C I. What is I? B D cube by 12. Okay. So I can find out all these values and substitute it over here. Okay. This is one way of solving the problem. Another way of solving the problem is, if you remember what I told you, that the tau max is maximum at neutral axis, and what is the formula? 1.5 tau average. Okay, and what is tau average? Tau average is nothing but shear force upon area, right? So I can use this formula. It will be very, very simple for me, right? So I will use this formula. What is it? Tau, that is equal to 1.5 tau average. Okay, and What is tau average? Tau average is nothing but shear force upon area. Okay, so we can substitute the values over here. So tau they have given us 5 is equal to 1.5 into tau average is shear force upon area. So that is equal to 1.5 into what is the value of shear force they have given? They have given shear force as 150 kilonewton. If you remember, I told you, you have to put all in the same units. So, okay, so I'll put it in terms of Newton. So I multiplied by 10 to the power 3 divided by area. So area is B into D. What is B? 150. D I don't know. We have to calculate. Okay. So when you solve this, you'll get the answer as 300 mm. Okay. I have taken a very simple problem. Okay. I think with this we end our session for the shear stress distribution. That is, we have just derived the formula how to calculate the value of shear stress, and we have even derived the formula and seen the shear stress distribution for a rectangular cross section, and we have done one numerical based on that. In the next lecture we will go for T section and I section. Have a good day. Bye. Thank you.